so another topic tayo for friction. So ito naman yung tinatawag na impending motion. So basahin muna natin. So guys, before we start pala, ito yung mga problems kung saan ina-analyze natin if yung object mo is magkaaroon ng tendency na tumaob o mag-toppled over. So okay, basahin natin. So under impending tipping, ayan nga, tipping or yung isipin mo na lang parang ano ka, patatakid, tataob. So in the preceding article, we restricted our attention to sliding. So before kasi, ina-analyze natin yung object as mag-i-slide lang. Pine-prevent ng friction na mag-slide yung isang object. So the possibility of tipping was neglected. So hindi natin siya gina-consider. So we now discuss problems that include both sliding and tipping as possible motion. So isang palatandaan dito guys is ibinibigay or ini-specify yung distance t. So ano ba yung distance t mo? Ito yung distance ng force p. Ito yung force which will cause the object to move. Okay? So aside from that, nandyan din yung mga dimension. Bibigay din yung dimension ng iyong, for example, for this problem, block. And yung center of gravity ng object na yun. Okay, consider again a homogeneous block on a friction surface being pushed by the force P as shown. So ito nga, yung figure natin. So we assume that the weight W of the block, so saan ba makikita si weight again? So again, ang weight mo is always acting downward or to the center of the earth, and lagi siya mag-act sa center of gravity ng isang object na ina-analyze. Ayan. Okay. So we assume that the weight of the block W and the dimension D, H, and T. D, H, and yun din nga. And we wish to determine the magnitude of P that will cause impending motion of the block, either impending sliding or impending tipping. So dalawa na yung i-analyze natin dito. Una is yung mag-i-impend sa sliding, and pangalawa is yung tipping. Okay? So dito tayo ngayon. So ayan. So we gain insight into the solution by comparing the number of unknowns with the number of available equilibrium equation. So by comparing the number of unknowns with the number of equilibrium equation. So same lang din naman yun ang pagsasolve kanina. So di ba gumagamit tayo ng summation of forces x and summation of forces y. This time, gagamitin natin yung isang equilibrium equation, which is the summation of moment. Okay? So from the free body diagram of the block, which is shown dito sa second figure, eto, we see that there are 4 unknowns. So the applied force P, so aside from that, the resultant normal force N, ayan. So kung mapapansin yung N, so that is acting at a distance x. Okay? Kasi ito na nga, kino-consider natin yung tipping over or yung bigat niya or yung normal force, I mean, is mag-a-act at a certain force at a certain distance x away from the center of the block. So, nasa na tayo? The friction force F or yung F sub F natin, yung frictional force, again, same lang din naman ang concept siya. It's always opposite the direction of the motion or opposite sa direction ng mga force na naka-act sa'yo. And the distance x that locates the line of action of N. Ayan. So, unknown din siya. So, because there are only 3 independent equations for equilibrium, ayun nga, summation of forces x, forces y, and summation of moment, and additional equation must be found before all unknowns can be calculated. So, dito papasok yung equation mo for the maximum frictional force o yung mu times n. So, if we assume impending sliding, the additional equation is, yun nga, f sub f or yung f max natin is equal to mu s times n. On the other hand, if impending tipping about corner A is assumed, so lagi naman nasa corner kasi pag ina-assume natin, di ba? Kung i-imagine mo kasi because of this load P, ang mangyayari doon sa block mo, dito ko lang i-drawing. So, ito yung point A mo kasi, di ba? So, because of this load P, para nagkaganyan. So, tataob siya. Okay? So, on the other hand, if impending tipping about the corner A is assumed, the additional equation is x is equals to b over 2 or kalahati nung iyong base, which is correct naman, di ba? Ayan. Ilipat pala natin kasi sulat pala si type 1 doon. Ayan. So, ito si point A. Okay? So, in the preceding article, 3 classes of friction problems were introduced for impending sliding. So, this classification can be easily rewarded to include the possibility of impending tipping. So, again, meron tayong mga different types dito or category for this type of problem, which will include the tipping. So, meron ka ulit tatlong types. So, the first one, so the problem statement does not specify impending motion, neither sliding or tipping. So, agaya doon sa kanina, walang na-specify. Okay? Type number 2, the problem statement implies impending motion and the type of motion, so sliding at known surface or tipping is known. And the last one, so the problem statement implies impending motion but the type of motion for the sliding or tipping and or the surface says where sliding impends are not known. So itong type 3, yung medyo madugo ng konti. Okay, so para mas maunawaan ito, mag-solve tayo ng mga sample problems. Okay, so for our first problem, basahin natin guys. So the man in the figure shown is trying to move a packing crate across the floor by applying a horizontal force P. The center of gravity of the 250 Newton, so ang weight ng kanyang crate na to is 250 Newton, which is located at its geometric center. Ayan. So sa pinakagitna niyan, dun mag-a-act yung iyong weight ng crate, which is 250 Newton. So sabi niyan, does the crate move if P is equals to 60 Newton? So the coefficient of static friction between the crate and the static floor is 0.3. Okay, so this type of problem will be categorized as type 1 problem. Bakit? Because the problem statement does not specify impending motion. So to determine if the crate moves for the condition stated, we need to check first the assumed equilibrium and check the assumption. Okay? So, bago ang lahat, gawa muna tayo ng free body diagram para makita yung mga forces na nag-a-act dito sa crate na to. Oh, sorry. Tagilid. Last. So, assume nyo na lang na ano yan na tuwid yan. Hirap talaga. So, gawang ko lang x and y axis. Ano yan tuwid yan. Ayan. So, meron ka ditong force P applied. Ito nga yung P natin. So, sinasabi dyan, yung P mo is equals to 60 Newton. So, ang tinatanong kasi dito is, ito ba, ang crate na to is gagalaw? Ano pa ba? Aside from that, meron ka ditong yung weight ng block mo. Again, sorry, nung crate. So, again, that is equals to 250 Newton. Okay, so sunod, let's just say na yung normal force natin, kagaya nga doon sa figure kanina, i-check natin if gagalaw ba yung crate natin. So kung hindi, at a certain distance na ganito, so let's just say that this is x and this is your normal force. Okay? So, aside from that, ano pa ba yung force na mag-a-act sa kanya? So, meron ka ditong frictional force. So, sabihin natin to as your point A. So, yung contact at point mo is yung point A. So, yung frictional force mo at point A. So, yung F, yun yung F sub A. Okay, so, check muna natin. So, check. So, i-check muna natin yung maximum allowable na frictional force. Gagalaw siya. So, that is equals to mu times n, but then again, yung n natin is still unknown. So to solve for n, so we need to take summation of forces y equals to 0, and considering this free body diagram, we could say that yung n mo is equals to 250 Newton. Knowing na 250 Newton yan, we can now solve for the value of the maximum possible frictional force. So that is equals lang sa 0.3 times 250 Newton. So the answer for that is equivalent to, saan ba yung calculator natin? So 0.3 times 250. So that is equivalent to 75. Okay? So yung maximum possible frictional force mo na pwede ma-experience ng body na to, so kung mapapansin nyo, that is greater than dun sa 60 natin. So what can we conclude dito sa na discover natin ito? Therefore, the crate will be static. So hindi siya gagalaw, at the same time hindi siya magta-topple over. So ibig sabihin yung assumption natin dito, yung sa n natin, tama yung location natin, which is equals to x. Okay? So, i-check natin kung paano natin makukuha yung distance na yan, yung x distance na yan. So, ang gagawin natin, knowing na itong force P to, ayan, that is applied at 0.9 meter. So, doon sa kalahati ng crate naka-applied yung force P. So, ang gawin natin siguro dito is mag-summation tayo ng moment dito sa point A na to. So, kapag nag-summation tayo ng moment at point A, yung n mo and yung frictional force will be concurrent at that point. So, wala na siyang moment arm lang. So, ang force lang na i-consider natin is itong 60 Newton and yung 250 Newton. Okay, so by taking summation ng moment at point A equals to 0, considering this free body diagram, 1, so unahin natin yung 0.6, so that is 0.6, that is 0.9, 0.6, so that is 0.9 times 60. So itong 250 Newton will produce a counterclockwise. So minus, transpose ko na lang sa kabila, guys. So that is equals to 250 times x. So x will be equals lang sa, so 0.9 times 60 and then divided by 250. Okay, so that is 0.216. So guys, this is less than dun sa, diba ito is 0.6. Ayan, yung lapad ng crate mismo. So ibig sabihin yung kalahati niya is 0.3. So that is less than 0.3. So ano bang ibig sabihin kapag 0.3 yan? Less than 0.3. So the largest possible value for x is 0.3, which is half the width of the crate. So because yung x nga natin nakuha is equals lang sa 0.216. So as obtained from the equilibrium analysis of the summation moment. So since smaller yan, we can conclude that the block will not tip o hindi siya tataob. So ayun, the limiting static friction force dito is maximum na 75. And that is larger than yung force mismong naka-applied, which is equals to 60 Newton. So we can therefore conclude that the crate will not slide and the crate will not move if the applied P is equals to 60 Newton. Again, ang ginawa lang natin kasi dito, guys, is i-check muna natin yung maximum, diba? So para malaman natin kung gagalaw ba siya or hindi. Another thing is, kung mapapansin nyo, ang binigay lang na coefficient of friction is yung static. So from the problem itself, nagbibigay na siya ng clue na hindi siya dapat gagalaw. Okay? So otherwise, meron siyang value ng kinetic friction. Okay? So yung frictional force na experience nito, again, ito is for checking lang. So yung frictional force mo will just equals to the force P, which equals to 60 Newton. And therefore, the crate will not move and tip over. Alright, so let's proceed with the next problem. Alright, so for our second problem, kamukha nung kanina. So, basahin muna natin ulit, guys. So, calculate the force P required to cause tipping. Ayan, naka-specify na dyan na magtitip yung iyong crate of the packing crate in sample problem 7.8 or yung previous problem natin. So, same lang din naman siya ng properties. So, ito na yung free body diagram niya. Naka-specify na lahat dyan yung forces and yung point A mismo kasi magti-tip over na siya, so yung maximum distance yung consider natin or yung kalahati mismo ng crate or distance 0.3 from the center of the block. So paita lang natin dito. So ano ba pinapahanap dito? Also determine the coefficient, the minimum coefficient of static friction that permits tipping. Alright, so with this, hanapin muna natin siguro yung force P. So, paano ba natin mahanap yung force P natin? So, before we continue, let's write first the equation that we are going to use. Again, yung frictional force. We can use also summation of forces X, summation of forces Y, and summation of moment. So, for this problem, that is summation of moment at A. Okay, so analyze muna natin. So, ang gawin natin, since this is your point A, so ang inaano natin is to eliminate yung mga unknown forces. Kasi ang wala tayong value dito is yung FA, yung frictional force at point A, yung NA, yung normal force acting at point A due to the weight na 250 Newton, and yung force P, yung force para mag-cause na tip over yung iyong crate. So, ang gawin natin, take sum tayo ng summation ng moment at point A. So, bakit sa point A? Para ma-eliminate since wala naman perpendicular distance or moment arm yung FA at saka NA. So, let's write the equation. So, P, yung force P, times yung distance yung perpendicular distance, which is 0.9. Specify naman sa problem. And then minus, so since ito is minus na, transpose ko na lang sa kabila to make it positive. 250 times 0.6 o kalahati lang ng 0.6 or yung width ng crate or 0.3. So the value of your P is equals lang saan? Mas may calculate. Ito nga palang calculate ko. Sa desktop na pala. So 250 times 0.3 and then divided by 0.9. So, ang value natin ng P is 83.3333 Newton. So, ayan. Nakuha na natin yung isang pinapahanap. So, ano pa ba yung pinapahanap dito sa problem na to? So, also determine the minimum coefficient of static friction. So, using this equation, ayan, you could say that yung coefficient of static friction mo is equals lang sa F sub F all over N. But first, we need to solve for the value of N. So, how can we solve for N? So, by considering the whole diagram, kapag nagsummation ng forces ng Y, may relate natin yung N based do sa weight ng iyong crate, or NA, so based on this problem, is equals lang siya sa 250 Newton. Since may value na tayo ng NA, we can now solve for the value of the mu. Pero pala, kailangan din muna pala natin mahanap yung frictional force or yung F sub F sub A. So, ito, equals na lang to dito ha, para hindi tayo malito. Okay, so paano natin may relate yung dalawa? So, by taking summation of forces ng X, diba? We could say that yung F sub F mo o yung F sub A is equals lang do sa force P mo, yung nakuha natin kanina, which is equals to 83.333 Newton. Alright, so since given na lahat, we can now solve for the coefficient of static friction. So that is simply equals lang sa 83.333 or yung F sub F divided by yung N mo na 250 Newton. So cancel lang naman yung Newton. Ayan, cancel. So what would be the answer for that? So 250 divided by 83.333. Mali ang pindot ko. Baligtad. Inverse natin. 0.333. Pasensya na kayo, gutom na. Ayan. Alright, so yun lang. Next topic tayo. So ito naman is yung under ng friction between belt friction. And yung mga type ng problem na wedges. Anyway, yung wedges naman is ano lang din, application ng nauna nating discussion. Is sa law of friction. Okay, so for this example, ito is isang example ng problem for belt friction. So, to make the story short, guys, ang tatandaan nyo lang for this formula, though there are a lot of variation in other books ng equation, pero ito lang talaga siya. Tandaan nyo na lang to equation na to. So, T max all over T min is equals to E raised to mu. So, yung mu mo is yung coefficient of friction times beta. So, before kasi, do sa mga previous chapter, di ba kapag may pulley ka, yung tension do sa magkabilang side is equal. Kasi nga, ina-assume natin that yung pulley mo is frictionless. But since for this example, meron na siyang ibinigay na specific value ng coefficient of friction between the belt and do sa ating drum or pulley, ibig sabihin yan, magkaiba yung value ng friction sa isang dulo at saka do sa kabilang dulo. Meron dyang isang mas malaki compared dun sa isa. And based do sa pag-a-analyze mo, dun mo malalaman kung aling dulo ang magke-carry ng mas malaking load and aling dulo yung konting load lang yung dadalhin. Okay, so yun yung ibig sabihin doon ng Tmax at Tmin. Yung yun natin is coefficient of friction. Yung beta, so that is the contact angle between the cable, yung belt, and yung pulley or yung drum. So yung contact angle natin, kung ititingnan mo dito sa ating example dito, ang contact angle niyan is yung lahat ng tinamaan ng cable dun sa iyong drum. Okay? So ito siya lahat. Ito yung kailangan mong malaman kung ano yung angle na yan. Pero ito, yung beta dito guys is na-array dyan. Ano? So kung makukuha mo is in degrees, so you need to convert that to radian. So paano nga natin siya ino-convert? So it's di ba alam naman natin na in one revolution there is 360 degrees and that is also equals to 2 pi. So may radian yan. Yung radian nga lang is sometimes unitless siya or in radian. Okay? So bakit ko na isama yung revolution? Because there are some problems na in terms of revolution yung contact angle do sa iyong object na ina-analyze. Okay? So, ayun nga, nakadepende yan kung ilang revolution, kung ilang roll, kung ilang pulupot ng lubid yung ginawa. So, yung total angle na yun, yun yung i-consider mo for beta. Okay, so basahin natin itong example na to. So, as shown in the figure, a flexible belt placed around a rotating drum, ayan yan, of 4 inches radius, so pinakita naman sa figure, that is 4 inches, acts as a brake when the drum ABCD, ayan, is pulled down by the force P. So, hinigit niya ito pababa. And the coefficient of kinetic friction between the belt and the drum is 0.2. Determine the force P that would result in a braking torque of 400 pound-inches. So, meron ka ditong equivalent value ng torque. So, from the previous topic, ito yung tinatawag nating couple moment or yung C sub R. Ayan. Ito siya. Ayan. So, meron siyang C sub R with a magnitude of 400 pound-inches acting counter-clockwise. Okay, so if that is the case, so from that torque, malalaman natin kung alin ba dyan yung maximum and alin yung magiging minimum. So kung ikakat mo to, di ba? Lagyan natin yan ng cutting section. Ayan. So, which of these two is the Tmax and Tmin? Okay, so mag-base ka doon sa couple moment o yung torque na applied. So since this is counterclockwise and kung mapapansin mo, di ba itong portion na to is sumabay dun sa ikot wow, moment ka dito sa point O, di ba ito'y sumabay sa ikot nung sa C sub R? So, ibig sabihin, kung sumabay yan, ibig sabihin, ito yung ating T minimum. And kung magtutulong yan dalawa, syempre, ito lang yung nagre-resist sa kanya. So, ito yung tatawagan nating T maximum. Okay? So, I hope clear tayo dun, Okay, so dyan natin makukuha yung isang equation. So, kapag nag-summation ka doon sa point O, consider counterclockwise moment as positive equals to 0. So, ilatag natin yung mga equation. So, that is T min multiply by the perpendicular distance. Ayan. So, given naman yung radius niya. So, that is 4 inches. And then, plus, so ito, sumabay din naman sa ikot nun. So, that is 400 pound-inches. And then, minus T max times 4 inches equals to 0. So, i-rearrange natin siya. So, ang gawin natin, sa unahan yung T max. Okay? So, transpose ko na lang dito sa kabila. Okay? So, that will be T max times 4. And then, ito, transpose ko, minus T min. And then, times 4 is equals to 400 pound-inches. Ayan din yan nire-arrange ko lang. So, I will name this as my equation number 1. So, bakit ko ginawa yon? So, kung maalala nyo, doon sa calculator nyo, di ba meron tayong 2 equation, 2 unknown. So, that is under mode 5, 1. So, habulin natin yung ganitong form. Yung a n x plus b n y is equals to c n. So, lahat ng value ng x, so ito yung para kay t max, and lahat ng value ng y, that will be for the t min. So, yung c is yung constant natin. So, saan ba manggagaling yung isa pang equation? So, using this equation kanina, yung diniscuss natin kanina, ma-relate natin yung dalawa para makuha natin yung T max and T min. And once we solve for the T max and T min, tsaka naman natin masosolve yung value ng P. So, before that, we need to analyze first what will be the value of your contact angle beta. So, ito. Ito guys, walang problema, di ba? Ito kasi, obviously, equal siya saan? Di ba yung semicircle, that is equals lang sa 180 degrees. Ang problema natin, etong contact point na dito. Ayan. Ayan. So guys, ito kasi, supposedly, ito ay, ayan. Di ba tangent siya dito? Ito will form a 90 degrees. Ganyan. Okay? So, ito, once na-extend mo kasi ito, ayan. So, ito, 90 degrees lang din yan. And then, di ba, ito kanina, so this is equals to 180 degrees. So, if this is 60, ito kasi is also equivalent to 60 degrees. Ayan. Ito is also equals to 60 degrees. So, kung 60 yan, 90 ito, di ba ito is equals to 30 degrees. Also for this one. So, kung 30 yan and 60 ito, ito is also equals to 30 degrees. Ayan. So, ano yung total angle na to? Ano nga hinanap natin? Ano bang kulay pa? Ito na lang. Pink. Ito yung kailangan natin makuhang angle. So, that angle is equals lang sa 180 plus 30 and then plus 30. So, 180 plus 60. So, that will be equal saan? 240. Ganito kasi talaga tayo para sure. Plus 30 plus 30 or plus 60. Baka kasi mag-iba yan sa ano yan, normal yan sa engineering. Mga simple addition talagang ano tayo dyan, nalilito tayo dyan. Gusto natin yung mga komplikadong numbers doon tayo hindi nagka-calculate. 240 degrees. So, i-convert lang natin siya to radian. So, diba is 2 pi rad. over 360 degrees. Or pwede rin namang i-simplify nyo na pi over 180. So that is equals lang saan? I-simplify lang natin ha. So that is... Sorry ha, ano kasi ito eh. Kumabagal. Magkakaibang tab kasi siya. 240 times 2 pi divided by dot yung pinipindot natin. Pinudot natin yung calculate. Kasi nasa desktop siya. Mouse yung ginagamit natin. 4 pi over 3. Alright, so since meron na tayong value ganyan, we can now apply this equation. So, dito na lang natin isulat sa gilid. So, that is T max cross multiplication lang. So, equal siya and then transpose ko sa kabila. So, magiging minus na. T min e raised to mu nasan yung 0.2 times yung beta na naka-array dyan. So, that is 4 pi all over 3. Guys, dito wag malilito dito kung ba't naging minus. Inano ko lang yung cross multiplication tapos nilipat ko lang sa kabila. Shortcut natin kasi kayo naman alam kong malalaki na. So, simplify lang natin yung e raised to 0.2. So, nasan nga yung e dito? Ito, yung kasama ng ln. E raised to 0.2 times 4 pi. Where's pi? Divided by 3. So, 2.3111. Sulat na natin. So, T max minus 2.3112 of T min is equals to 0. Ayan. So, to equation 2 we can now use yung mode 5. Mode equation 5 1. So, saksak mo lang yung value. Again, yung value ng x is yung sa T max. So, unahin natin to equation 1. So, that is 4. So, minus 4 or negative 4 is 400. Okay, so para sa equation 2, so T max lang yun. So, that is automatic 1. So, negative 2.3112. So, kung hindi maalam gumamit nito, pwede naman kayong by process of elimination, diba? So, naituro naman sa inyo yun sa algebra. So, ayan. So, i-multiply mo lang to ng 4, tapos i-subtract mo para makancel yung isa, yung T max. Manap na yung T. Para mabilis lang din, eto na lang. Gamitin natin ng ship solve or yung mode equation. Okay, so for T max, we arrive at an answer of 176.2660. And for the T min, so that is equivalent lang sa 76.2660. Alright, so that is in pound. Forgot. So after this, ano sunod natin gagawin? So punta na tayo dun ngayon sa pulley. So yun sa pinagputulan natin. So kung i-drawing mo siya, ito yung makikita natin. Okay, so dito nga ulit yung iyong T minimum acting at an angle of 60 degrees. So kailangan natin yung angle na yan kapag nag-submission tayo ng moment. So ang kailangan lang naman natin dyan is yung y component. Kasi yung x component magiging concurrent siya dito sa point na to, doon sa may hinge or doon sa point A. Kasi dito, di ba, pag hinge merong reaction. Pero since dito tayo magmo-moment, we can neglect this reaction kasi magko-concurrent siya or tatama siya sa point A. So, no need to consider that. So, ano pa yung sunod natin consider? Ito, yung T max. So, that is also acting at 60 degrees. And last, at the end, so that is our P, yung unknown. So, given naman yung mga distances nila, so this is 2 inches. This is 4 inches. And then, this is 2 inches. Okay. So, again, dito tayo magmo-moment sa point na to. Sa point A. Okay, so, when we take summation of moment at point A, considering this free body diagram, ayan, yung beam, or itong may hinge na to. So, P, unahin natin yung P multiplied by 2 plus 4 plus 2. So, that is 8. So, yung y component nitong dalawa will produce a counterclockwise moment. So, minus na. So, transpose ulit natin sa kabila to make it positive. So, unahin natin yung T min. So that is 76.2660. So to get the y component, multiply mo lang ng tama. So that is sine 60. Then multiply by the distance. Ano lang to y component pa. Don't forget the perpendicular distance, which is 2 inches. Okay, we're done with that. Next is for the Tmax. So ganun lang din guys ang gagawin. 176.2660. So kunin mo lang yung y component, multiply mo ng sine 60, and then times is 6. Ayan. So, okay, pindutin natin siya sa calculator. So, 76.2660 sine 60. Sine 60 times 2 plus 176.2660 sine 60 and times 6 and then divided by 8. So 131. So the answer is 131. Okay na yan, 131.0 pound. So this is our final answer. Okay, so sa mga ganitong problems naman, guys, ang kailangan, pinaka-importante lang naman dyan is to identify which is Tmax and Tmin, at the same time, to know the contact angle na andun sa iyong belt friction. Yung tinamaan ba ng lubid agad. So, there are some problems, guys. For example, meron ka dito murad, kung saan meron kang rope na nakapulupot dito. For example, yan, 4 na buhol. And ito kasi may kine-carry na, for example, W. And doon sa kabilang dulo, papahanap sa inyo yung load P. So, di ba kaya mo siya niro-roll na doon sa pole na yun para at least kaunti na lang yung force na i-apply mo to carry that load or yung weight na W. Okay? So, it's either bilangin mo yan, papakita sa figure yung itsura kung ilang roll ang ginawa, or i-specify naman sa problem kung ilang roll or revolution yung ginawa. Tapos siya mo siya again i-convert into radian. Again, naka-radian dapat lagi yung beta mo or yung contact angle. Okay, so yun lang naman yun. Let's continue and proceed with the next discussion.